Hello everyone. So last segment we saw some basic logical equivalences. So in earlier segmented also we actually saw that we can use truth table to find out whether two logically equivalent, whether two statement is logically equivalent or not. Now instead of finding the truth table, we can also use the concept of some basic logical equivalences to prove that whether two statement is logically equivalent or not. Okay, so in that case what we can do, actually having a compound statement, we can actually simplify a statement. Okay, simplify a statement using some logical equivalences, then we can find out actually another form of the same statement. So let's see an example. Let's see a given statement looks like that: P and Q or okay, so P and Q are not P or Q. Okay, so we are going to try to see whether we can simplify the statement. Then the simplified statement will be actually logically equivalent to this statement. All right, so we have here P and Q. All right, now if you think about that, we have the NOR operator or negation operator, and negation is going to be, and here the negation implies for both here. Okay, so negation of P or Q. Okay, so this statement is like that. So if we implement the De Morgan's law on that, so this is equivalent to not P and not Q. Okay, so instead of not, you can also use this symbol. All right, not we can use both this symbol and tilde symbol for both not. So this is same as not P, it is going to negate both of them. So P and P and not Q. Okay, so using implementing the De Morgan's law, we are going to find out from that this format: P and not Q. Okay, all right, now from that what you can see. Okay, so this is actually a here we can see that P and Q or P and not Q. Okay, P and Q and P and not Q. Okay, so this is same as writing P and Q or not Q. Okay, so let me just explain you. The distribution law is looks like this: P uh, here the distributive property looks like this: P or Q and C, we can actually distribute this operator for both. So P or Q and P or C. Okay, so same as for if we change the position of and or operator. So here actually looks like this. Say if we have for this one, so if we have a statement like this: P or P and Q or not Q. Okay, so if we implement the distribution property, if we distribute this AND operator to both of them, this will look like this: P and Q or P and not Q. Okay, so here we see the same. Okay, now that means they are same. Okay, so this is same as this, that means these two are same. All right, now what do we see? Q or not Q. Okay, if we find something like that, Q or not Q, that means actually we can see that this is same as complement property. P or not P means always true. Okay, so Q or not Q, it will be always true. So P and true. Okay, then we can implement the identity property. So P and true means always P. Okay, so it will be P. All right, so here we are going to use, we are using De Morgan. Here we use the distributive law. Okay, here we are using distributive law, and here we use the complement property. Here we use the identity property. Okay, finally we can see the simple version of this statement is P. Okay, so we can say that actually they are logically equivalent. So this statement P or Q and they are logically equivalent to P. Okay, so here this is another way. By simplifying one statement, we can find out whether this is logically equivalent to some other simple form of a statement.